All right, good evening, everybody. Today we're going to be going over practice of problem solving for generating equivalent expressions. So let's start with number 8. It says for 8 through 10 to fill in the boxes to complete the problems. All right, number 8 says evaluate 10.2x plus 9.4y. Remember these x's and y's, these variables as we call them, they just represent some number that we don't know yet. In this case, they tell us what the number is. They say that x is 2 and y is 3. So over here, where it has 10.2 times x, and it wants us to tell us what is in this bubble, well, x is 2, so we would write the number 2 there. Next, we see that 9.4 is multiplied to y, and y is 3, so over here in this bubble, we would put 3. Now they're wanting to ask us what is going to go in this first bubble. Well, it's 10.2 times 2. And 10.2 times 2, we'll just do the math over here. I'm fairly certain it's going to give us 20.4, but we'll just follow it out here. There's 4. This would be 0, and that would be 2. And with one decimal there, 20.4. So right inside here, 20.4. Now they want us to add these two together in order to get our final answer. Well, we'll just do that over here, 20.4. We're going to add that to 28.2. And notice how I line my decimals up so I make sure I don't make any mistakes. Well, 4 plus 2 is 6. 0 plus 8 is 8. And 2 plus 2 is 4. So our answer is going to be 48.6. All right, number 9 is for you to do. I'm going to number 10. Write an expression that represents the height of a tree that began at 6 feet and increased by 2 feet each year. Let y represent the number of years. Well, y is the number of years, and it says that it increased by 2 feet per year. So that means this 2 is going to go here next to the y. Because if y is representing years, and this is 2 feet per year, then that's 9 times every year, that, or 2 times every year that goes by. And since it began at 6 feet, 6 feet is our starting point. So we'll have 6 plus 2 times y. All right, let's go to number 12. Evaluate each expression for the given value of the variables. Okay, well, over here they've got 0.5f minus 2.3g. And basically, if f equals 12, this is really going to be 0.5 times 12 and this is going to be minus 2.3. Well, if g is 2, then that's times 2. And we're ready to go. Let's see here. Well, first of all, we got to figure out what is 12.5. We'll do the math over here. 12 times 0.5. I'm pretty sure that's going to give us 6. Let's just check it out here. Well, 2 plus 5, or 2 times 5 is 0. Carry the 1, and 5 times 1 is 5, plus 1 is 6. And we have to put our decimal back 1, so that's exactly right, 6. And now 6 is going to be minus something. 2.3 times 2. Well, 2.3, if I multiply that to 2, well, 3 times 2 is 6, and 2 times 2 is 4. So that's going to be 4.6. So number 12 is asking us, what is 6 minus 4.6? All right, so 6 minus 4.6. We see here that we have to put our decimal there and a 0. I can't take 6 away from 0, so I have to borrow 1. which turns out to a 5, is a 10. Now, 10 minus 6 is 4. The decimal comes down, and 5 minus 4 is 1. And since 6 is bigger than 4 minus 6, we're going to keep the positive number. So our answer for number 12 is 1.4. All right, let's go to number 14. We've got 34 plus 4 over 9w. They're saying that w is negative 1/2. So this problem is really 34 plus 4 over 9 times negative 1/2. Okay, we can remember that when we do PEMDAS, we have to follow the multiplication first. What we have here is a fraction multiplied to a fraction. And we know when we're multiplying, we just multiply the numerator to the numerator and the denominator to the denominator. Basically, the top to the top and the bottom to the bottom. So we can rewrite this. This would be 34. And well, we know that a positive times a negative is going to give us a negative. So this is going to be negative. 4 times 1 is 4. And 9 times 2 is 18. Now, if I wanted to, I could have used my butterfly method and just went ahead and crossed this out, made a 1, crossed this out, made 2, and I would have got 2 over 9, which basically that's what this is going to be reduced to. So I'm going to erase this and turn it to 2 over 9. All right, so now they're asking us, what is 49 minus 2 over 9? Okay, so now we're going to have to go ahead and turn one of these, well, we got 34 here. We're going to have to borrow one to make a fraction. Because 34, we could say, is the same as saying 33, let's see, plus, well, we could say 9 over 9, right? So let's see, 9 over 9. Let me examine this closely. We do have to go ahead and add one little thing, and that's going to be a plus sign in between. So what we really have is 33 plus 1. So if we rewrote this, it would be 33 plus, let's see, 9 over 9 minus 2 over 9. And if we did that, we could see that 9 minus 2 is going to give us, I'm sorry, that is incorrect. We don't need that plus sign there. I don't know why I thought that we did, but we really don't need that plus sign there. It is 33 and 9 over 9. And now 9 minus 2 is 7. So that's going to give us 7 over 9. So this answer should be 33 and 7 over 9. And that's it. If you wanted to, you could have did it a different way by taking 34 and putting it over 1. If we did that, we would have something like this, 34 over 1, and we'd be subtracting 2 over 9. Well, then we know we'd have to turn this into 9, which means we'd be multiplying this by 9 and this by 9, right? Let's see, so that would be, let's see, 9 minus 9, this would be 2, And what is 34 times 9? Wow. What's a calculator for that? 34 times 9 gives me 306. And it would be 306 minus 2, which would equal 304 over 9. Now we'd have to see how many times does 9 go into 304, because every fraction is really a division problem, right? So I'm running out of room, so I'm going to erase some of this up here and do my division here. 304 divided by 9. Well, 9 goes into 30. Let's see. That's going to go into 33 times, because that would give me 27. And that would give me 34 left over. And once again, we go into it 3 times. Give me 27 again. And this time it would give me 7 left over. And that's how we get our 33, right? And 7 over 9. Okay, same answer. All right, let's move on to number 16. I'm doing the even. Model with math. Which expression can be used to determine the total weight of a box that by itself weighs 0.2 kilograms and contains P plaques, in other words, a certain number of plaques that weigh 1.3 kilograms each. So remember, the box is 0.2, that's what's going to stay the same. And then we're going to multiply 1.3 times P. So let's see, we got 1.3 times P plus 0.2. Well, that to me sounds like it works just fine. Let's check the next one. 0.2 times P. Well, that's not true, because remember, 0.2 was the box itself. The next one is 0.2, and that's the box, minus 1.3 P. Well, that won't work because we're subtracting the number of the weight of the plaques, excuse me, and that's not what it's asking us. Next is 1.2 P, and that doesn't work either because, well, none of these weigh 1.2. All right, so our answer would be A. All right. Let's see, the last one I have is number 18. Number 18 says a full grain silo empties at a constant rate. All right. Write an expression to determine the amount of grain left after S seconds. Well, we don't know how many seconds are going to go. We do know the silo here has 3,000 looks like cubic feet of grain in it. And if we're going to say how much we're losing, the amount of grain that's left after this, we're going to have to start with 3,000 because we're losing grain, right, after seconds. So we're minusing grain. And this grain is going out at 3.5 feet, cubic feet per second. So that would mean we're minusing 3.5 times S. All right. So that means depending on how many seconds go by, we're multiplying that to 3.5 because that's how much we're losing per second. And the grain is only 3,000, so after so many seconds, we're going to run out, so we have to have 3,000. So my final answer would be 3,000 minus 3.5 S. Well, it looks like that's all of them that I was going to do tonight. The rest of them are up to you. So have a good night, and I'll see you in class tomorrow.